Well, I kind of haven't slept all night because I've been dealing with engineers who complain about broken pipelines to engineers who said that engineers broke the pipelines. So what's the point of having CI/CD and whatnot? Well, obviously I'm lying, I have slept, but just to get a little bit of your attention and to show the motivation of why. So, for those who have no idea what the CI/CD is, quickly, if you have a process in software development team, which you do, like let's build this thing, let's test this thing, let's deploy this thing somewhere. So CI/CD means that we automate this process, put it in a pipeline, and make it run by itself. So if we have this so-called DevOps, if we have the CI/CD, then why some people have those sleepless nights when engineers look at the broken pipeline and the production is failing, and so on and so on? What causes that? So typically it's three things. One is the configuration drift, which is we built one pipeline and it worked. We built another similar pipeline, it worked. Then someone changed the first pipeline, forgot to change the second pipeline, and you can imagine what happens next. That's the configuration drift. The second thing is just repeated engineering effort. If we have third pipeline and fourth pipeline and fifth pipeline, which all are similar, we're kind of redoing the same thing because apps generally are similar. If it's the same technology, if it's the same purpose. Then cross-role communication barriers, that is truly about developers versus DevOps versus testers, everyone having their own language, their own expectations, what is the right way, how to do engineering, and so on. The solution, our approach. So first of all, we are saying that let's use model-driven engineering approach, which means let's this process of pipeline, let's put it in a model. I'll get back to that. Then, of course, all these pipelines, we could automate them. Why do we need a DevOps engineer coding them? If we have modeled that, then we can generate the pipeline. And finally, instead of having 10 different pipelines to update each time by that poor DevOps engineer, let's have a centralized approach and deploy all 10 pipelines where they belong. So quickly on the research design. So we put up a central hypothesis. Software architecture models can be systematically transformed into consistent, reusable, and maintainable DevOps pipelines using MDE principles. To prove this hypothesis, we raised three questions. One is that doable whatsoever? Is there a solution which could prove that hypothesis technically is doable? Then does it actually help? If we make this tool, is engineers going to benefit? And number three, if it works, does it work correctly? Can we trust it? So the solution, we built it. I'll be honest with you, it's still a rather, not like a prototype, but it's still a bit small, but the first results are here. So, first of all, the architecture consists of three layers. The first layer, we have in the input a system architecture model. I'll show a small picture on the next slide. We have a simple model in the input. Everything else gets generated. So at the second layer, we have the MDE principle where we have the platform independent model, then the platform specific model, then a bunch of transformation rules to get down to the actual code, which is the level 3. This is how the same thing looks visualized. This is a primitive picture. The real stuff becomes a little bit more complex, obviously. But if we think of, this is a super simple Java application, like one library. That would be in the input for a simple Java library. And then the second one is the platform-independent model of a DevOps pipeline, which means it's not Jenkins, it's not GitLab, it's not GitHub. It is platform-independent, any pipeline. But then we tie it up. There in the middle actually is a PSM meta model, which is for GitLab specifically, and we generate the GitLab pipeline code out of it. And this picture is how the GitLab shows it. That is GitLab specific. So if we have this, we can swap this PSM to GitHub Actions, to Azure DevOps, to Bamboo, to Jenkins, to TeamCity, whatever. That's something very important to keep in mind. So, does it work? Of course it does. Otherwise I wouldn't be here. Then what we did, the case study is a company which is building chatbot ecosystem. In the middle there is, or at the bottom, there is one build, one pipeline which creates a Docker image and pushes that to container registry. And then the 9 kind of subsequent pipelines take that image, updates it for specifically that customer specific chatbot, and pushes the new image out and then deploys that to the servers. So it's one core, 9 implementations. And then it also enforces 80% test coverage, some linters, typical things what we would have on a pipeline. So did it help? Okay, we did the technical thing. Did it get better or did it get worse? Then we see, first of all, the 96% improvement in onboarding reduction, which means when we want to start developing a new chatbot, and in the previous example, like the 10th chatbot, how long is that going to take to make a pipeline for that? Now, because of the tool, we have gotten it down to 10 minutes. Instead of previously, it was, now we need a DevOps engineer, let's find that person, now let's explain to that person what we need, that it's going to be the same as the previous ones, and then finally, after a couple of hours, it's up and running and tested and etc. Hopefully in the same way as others are. Then 95% reduction in platform migration. So if the chatbot was running on some other platform, let's say GitHub Actions, then how long does it take to now migrate that pipeline code to GitLab pipelines? Previously that was taken a couple of hours. Now, since it's all fully modeled and automated, that's also down to roughly 10 minutes. And then new rule, and that's kind of the most interesting one. So it's not just about generating the pipeline. Yeah, we code the pipeline once and then forget about it. Not true. We make the pipeline once, and then someone comes and says, hey, let's add this security linter, let's add this step, that step, additional test, additional packaging, additional this and that. So we need to maintain our pipelines all the time. That's what those DevOps engineers are doing. So a new rule, and here you see typically 3 hours, a simple new rule adding that to pipeline. That includes testing of the pipeline, execution, checking artifacts, and so on. And then to do the same thing in the MDDOAI tool, the first step takes longer because we need to now update the meta model, we need to update the model, we need to test the full flow. But once it's there, then we will be able to propagate that same functionality, same linter to any pipeline. Then we did a developer experience survey where we found out an interesting thing. It was 7 constructs, it was 13 different questions to a group of people, to real people who work in that chatbot ecosystem. And we found out that the software or system architecture model is favored for communication and cognitive load, while the DevOps or CI/CD pipeline YAML, of course, by experts is valued by shared understanding, onboarding, and trust. But this opens new ideas for, hey, if we get everyone in the same room, let's talk about the software architecture model instead of some pipelines which no one understands. Then we proved that it works. We went through all kinds of tests. It deploys, it generates the same code every time. It's not LLM, no surprises, it's deterministic. Then in the discussion, just finish it up because I'm out of time. Of course, there are threats. It's done for now in a single ecosystem for a specific technology. So basically for one case. But we're super lucky that we had this case. It's so hard to find real engineering teams who are open to such experiments. So this is it. Then, of course, initial cost goes up because you need to implement the tool, you need to develop the models for the first time, but in the long term, it pays back, it pays off. So, on conclusions, we found out that this is doable. We have proven the hypothesis correct. But then more interesting is the future work, where, of course, we want to expand it. It's already done for 2 other platforms, but we want to expand it to all the CI/CD platforms, and the list is pretty long. We want richer architecture models. Think microservices architecture, 50 different microservices. Today you're using Azure DevOps, you want to move to in-house GitLab. It's going to be a huge engineering effort. With this tool, if it's ready, it's going to be, well, more than a couple of hours, but definitely a way less than send a DevOps engineer to code all of that by hand. And then larger scale validation, larger projects, more application, and so on and so on. Yeah, thank you, and that is mddoai.com.
So you finished 1 minute early, so we have time for some questions. Yes.
The model that drives the pipeline, that needs to be manually built?
For the first time, yes.
Yeah, okay, but have you thought about reverse engineering an existing pipeline using an LLM? Essentially, you have this developer team, this Zen IS or however they're called, they have a pipeline already, and many developer teams will have. Take this as an input for an LLM and tell it, hey, give me the output, kind of the model, because the model, as far as I saw, is code driven, right?
Yeah.
Have you tried that?
Not exactly in the same way, but kind of you're leading to my next research, to my extended research. So let's talk about the bad stuff, okay? So here, what we don't really see, it is said there, initial cost, long-term gain. The initial cost is not the cost, it's poor engineers who now need to learn what is ATL, what is OCL. It's a completely new, different language. Not developers, not DevOps engineers, no one wants to learn a completely new language just to get this tool running. So the research, what we're doing now is we are using LLM to, it's not fine-tuning, it's for now based just on multi-shot examples, but we're showing to the frontier LLM, Claude still shows the best results, that this is how ATL looks like, this is how pipelines look like. If we show it a lot of documentation and examples, can it generate new meta models, that is abstraction of a model, then based on that, can it generate a model, and then at the end, the pipeline stuff is covered by the MDE principle. And we do have, I have already a paper written which has not been published, which shows that this works. So the next step is going to be adding that to this tool so that we can generate pretty much anything. And we call it, thanks to great professor Jordi Cabot, Vibe DevOps Engineering. Yeah.
Thank you for your presentation. I have one question about engineering, because we are working in engineering for more than 20 years, Jordi, Oscar, and so on. So, model engineering appears as a solution to model once and then regenerate or generate the code.
Mm-hmm.
So the code will be correct for the different pipelines and so on. However, for industry adoption, there is a problem with model engineering because they usually go directly to code and output. LLMs, they are going directly to byte coding.
Mm-hmm.
So what happens with this kind of learning curve? It usually happens with what I want to know your opinion, no? Because it usually happens with different companies that will collaborate. So for them, it's more easy to go directly to change these pipelines and do all the testing, do all the scripts, than to model once. Because learning how to model for them is still difficult. Okay? So my question is more, it's not a question more related to your opinion. With this solution, do you think that it will be more easy, the adoption of model-driven engineering at industry, or maybe it will be the same than these 20 years?
Yeah. It keeps falling. To comment on the, so we did the survey, we showed to DevOps engineers that this thing works. MDE in pipelines works. And they were still like, you know, I'll better go to my pipeline because fixing something takes me 5 minutes and it's done, in people's heads at least. But then, of course, they have learned that skill. And then with this, we want to, plus the new research which I told you about, we want to get to the level that we don't talk about MDE anymore. We're talking only about, hey, this is the input model. You need to learn how to design a software model, which is, it is an extended class diagram plus more parameters, and that engineers who have been to a university know how to do, and that's it. And the rest we cover with the tool. So we don't even talk about MDE with them anymore. Of course, it's still a vision, yes, right now to add any rule. It takes a long time, yeah, and skills, but that's why I'm super excited about the next research.
Yeah, maybe a short question.
Okay, I can see the, if I understand correctly, you have a meta language to define the pipeline. I can see the language architecture. Is the language as a single giant language, or you have layered architecture for the language? Layered, I mean, because you want to support.
What do you mean by layers? Yeah. What do you mean by language layers?
For example, you want to support different pipeline types like GitHub or Jenkins or whatever. So that means they have some common concepts, but also they have some their specific elements or concepts. That means in your language, your meta language, you cannot include everything, right? You must have some extension.
I hope I understood the question.
Extension. So maybe that's why I ask, do you use a layered language architecture, or you put everything in one model?
Everything is in one meta model, which is used to firstly build the language. And in that meta model, we would say, for example, there is a type of command as an element. It may have test, build, this and that. So we first define the language. We do that in the meta model. And then based on this meta model, we start building models. It's not an endless options of how this language could be. No, because we know at the end what we want to build. So it's I don't know, several million or billion options, but it's not endless. So we know that DevOps meta model, which consists of everything what we may want to do, is finalizable. So we define the language. The meta model is that layer, really.
We can just take it offline.
All right. Thank you.
Thank you.